Hi guys, so our last topic that we're going to learn about this year is the Pythagorean Theorem, and I like to go over this at the end of the year because it's actually not in your textbooks, which is interesting because Pythagorean Theorem is a big part of 8th grade math, and this is an accelerated course, so I would have thought it would be in there, but it isn't, so I decided to add it in myself. I also like to go over it at the end of the year because when you guys take your Catholic high school entrance exams next year, the Pythagorean Theorem is on it. So it's good to have yourself, it's good to go over it at the end of the year so you have a little bit of a background with it. When we start to review next year at the beginning, September and October, getting ready for the CHSE, then we will be focusing on that. And I don't want it to be brand new for you. I want it to be something that we're reviewing. So make sure you take this lesson seriously. This might take a little bit longer than our usual videos just because I've broken it up into a bunch of different parts here. So before we begin, in order to do the Pythagorean Theorem successfully, excuse me, we have to be okay with square roots. So this is just a quick review of square roots. This is the same lesson that I used with the 8th grade when we prepare for the CHSE and when we go over the Pythagorean Theorem, so wanted to break it up for you. When we have to find a square root, what we're asking ourselves is what number multiplied by itself gives us the number under the radical, right? So we went over this already, but for example, when we're finding the square root of 100, we're asking ourselves what number multiplied by itself gives us 100. So we know that 10 times 10 gives us 100. So when we find the square root of 100, the answer is 10. So for the square root of 36, we're asking ourselves what number multiplied by itself gives us 36. So we know from our multiplication fact, 6 times 6 equals 36, right? So the square root of 36 would be 6. And then this goes as well for variables. So if we took this, you guys know this though, we went over this, but we take the square root of x squared, we're asking ourselves what number, or in this case, variable or anything multiplied by itself gives us x squared. So we know that x times x gives us x squared. So when we take the square root of x squared, the answer is x. Okay, now it's something we did learn during the year. Now, on your Catholic high school entrance exams, you are not allowed to use a calculator. However, for our purposes here, learning about the Pythagorean Theorem, if you do have to take a square root of a number, you can do it in the calculator. I did show you guys in school, but just to remind you, if you are using a graphing calculator such as a TI-84 Plus, you see that you have your square root button here. It's above the x squared button. So remember, the color of your symbol corresponds to the button you need to push. So in order to get that, I have to push second, and then I push the x squared, and that gives me my square root sign. So if I wasn't sure what the square root of 100 was, whenever they show you that little arrow, that means to push that way to get out of the square root sign, okay? All I have to do is push enter, and it'll give me my answer. So let's say you're being asked for the square root of 196, and you don't remember what it was. So just plug it in your calculator, and you'll see, okay? But I do want to warn you that on the CHSE, you are not allowed to use your calculators. It all has to be done by hand. So it might be good to get a little practice. Okay, so we're going to do a quick check. I want you guys to just pause and give these 4 a shot, and then unpause and make sure you got them right. Okay, so hopefully you got these nice and easily. The square root of 81 is 9, because I know 9 times 9 is 81. The square root of 25 is 5, because 5 times 5 is 25. The square root of 4 is 2. And the square root of y squared is y, because y times y is y squared. So if you were confused by this, just a helpful hint, whenever you have a variable that is squared, the square root of it is always just going to be the variable by itself. Okay, so if this was m squared and we had to find the square root, it would always just be m. Okay, because m times m is m squared. All right, so let's move on. Let's talk a little bit about right triangles before we go into the Pythagorean theorem. So we have talked about this before, but again, it's just a review so that we're really ready to go. Right triangles all have a right angle. That's here, and it's represented by a little box such as this. They have what are called two legs and then a hypotenuse. Okay, so this is a leg, this is a leg, and this is a hypotenuse. And one of the helpful ways to remember if it's a leg or not is to see if it makes the L shape like this, L for leg. Okay, and the two sides that make up the L are the legs. Okay, so another way to think of it are that the legs are the two sides that form the right angle, and the hypotenuse is always opposite. And it usually looks like it is diagonal. But I don't want to say that always because, you know, sometimes your triangle can be turned around and facing a different way. So here is my little picture for you. On the smartboard, this would have been like a touch screen and it appears. So this is just everything all displayed. So here's the right angle like I just drew for you. The hypotenuse is opposite of the right angle, and it's always the longest side. That's important to know. And then the two legs, like I said, they form an L around the right angle. Okay? They're the two sides that form the right angle. And if you ever forget, you can see that they make an L shape. So quickly, let's just label the hypotenuse on each of these. Purpose of this is to show you that, like I said before, the triangles are not always facing the same way. So the way that you always want to identify the hypotenuse is that it's opposite the right angle. That's the way you want to do it. So you find your right angle and you go opposite. So this is your hypotenuse. We're just going to do HYP. Okay, so here's my right angle, opposite. This is my hypotenuse. Here's my right angle, go opposite, and this would be my hypotenuse. And again, here's my right angle, go opposite, and this is my hypotenuse. Okay, that's how you decide where the hypotenuse is. Okay, so now if we can find the hypotenuse of a right triangle, we're halfway there because we have now identified the one thing that we need to identify before we start using the Pythagorean theorem. So here it is. The Pythagorean theorem gives us a way to find a missing side of a right triangle. The only time we can ever use the Pythagorean theorem is with right triangles. If you don't have a right triangle, you cannot use this. It tells us that the square of the hypotenuse is equal to the sum of the squares of the legs. Now I don't have it. Okay, so there is a whole proof to show this, but I wanted to just quickly show you the idea of it. So if you have a right triangle like this, okay, what they're telling us is if we took each side of this triangle and we created a square of its length, right? So like this is not going to be exact, of course, right? Right, so let's say this is the square for this one, for this side, and then I took this side and I created a square based off that length as well, okay? The idea is if I add these two squares together, and I mean the area of those squares, if I count it up, you know, what they usually do when you show a proof is you can see like a grid and you can count. And I make a square of my hypotenuse length, what you will find is that this square is equal to the sum of these two, okay? And because of this, we are able to use a special equation called the Pythagorean theorem because we know that this length, when we square it, it's equal to this length squared plus this length squared. So here's how it works. What we do first is we separate our legs from our hypotenuse. A and B are the legs, okay? So A and B have to be legs, and then C is our hypotenuse. So the formula is that we use A squared plus B squared equals C squared, okay? So, like I said before, the square of this length is equal to the sum of these two. So we're squaring them and adding them, and they're equal to this one squared. So it's a squared plus b squared equals c squared. Probably will never forget that. So here's what we have to do in order to use the Pythagorean theorem. First thing we do is we label what we have. Then we decide what we need to find, because sometimes you need to find a leg and sometimes you need to find a hypotenuse. Then you're going to square all your numbers, and then you're going to solve the equation for the side that you're looking for. So I'm going to show you an example of what I mean. This is the type of a problem you'll see. On the Catholic high school entrance exam, they did change the format a little bit this year, so I have to take a peek, but generally they've always asked this as a word problem and not displaying a picture. So I'll explain what I mean by that later on. But what we have here is a right triangle, and the first thing you want to do is label A, B, and C. The only thing that matters, A and B don't matter in terms of which one is which. C is the only one that matters. It has to be the hypotenuse. Okay, so this is your hypotenuse. So this is C, and this can be A, and this one can be B, or you can switch them. So once you've identified what your hypotenuse is and your legs, so you label A, B, and C. Now, if you chose to make this B and this one A, that would be fine. The only thing that really matters is C. So as long as you have the hypotenuse labeled as C, that's all that matters. Okay? Now we have to decide what we need to find. So in this case, X is the hypotenuse. So we're looking for the hypotenuse. So here's how we do this. We write the equation first. So it's A squared plus B squared equals C squared. And now what I like to do is I like to do A equals B equals C equals, just like I always do whenever I'm filling in a formula or an equation. So I have A as 3 and B as 4, and C is X, right? You could also leave it as C, it's up to you. So now we would do A is 3, so we're going to do A squared. In parentheses, you're going to put the 3 squared, plus B is 4, 4 squared, equals X squared. So we're going to square these numbers on this side first. 3 squared is 9, and 4 squared is 16, is equal to X squared. Now we add these two numbers here before we solve for X. I have 9 plus 16, which is 25, equals X squared. Now our last step, we have to undo what's happening. So we're going to take the square root of both sides. Square root of X squared and the square root of 25, so I can find that X is equal to the square root of 25 is 5. So X is 5. And that's it. Another example. This case, the X that we're looking for is in a different spot. So first thing we do is we label. So I see my L, these are my legs. My hypotenuse is opposite of my right angle, so that's my hypotenuse, which is C. And then like I said to you guys, it doesn't really matter which one's A and B, but I generally go from like left to right like that. So I'm going to say what it is that I'm finding. In this case, I have my hypotenuse. I have one of the legs. So I'm looking for the length of one of the legs here, not the hypotenuse. So when I set up my equation, A squared plus B squared equals C squared. This time I'm looking for one of the numbers on the left side, so it's going to be a little bit different. A equals, B equals, and C equals. So A is X, B is 8, and C is 10. So I'm going to plug everything in and see how it's different this time. So A squared is going to be X squared, plus B squared is going to be 8 squared, and again, it's going to always go in parentheses just to be thorough, equals C squared, so that's 10 squared. The difference here is that instead of doing everything on one side, there's going to be one extra step where we have to move this over, and that's it. So this is X squared, and then 8 squared is 64, so X squared plus 64 equals 10 squared, which is 100. Okay, you can, of course, if you don't know your perfect squares, you can, of course, use your calculators for this. And now this is like a two-step equation we have to solve, right? So before we can take the square root of X, we have to get the 64 over to the right. So we're going to do the opposite, which is subtract 64. And what I do to one side, I must do to the other side. So I get x squared is equal to, and then 100 minus 64 is going to give me 36. Okay, and now I can do my final step, which is going to be to get x by itself. So I have to undo the squaring by taking the square root. Take the square root of both sides, and x is equal to, square root of 36 is 6. So now I found x, which is 6. Okay, it's not as bad as it seemed, right? One more example, so I'm going to have you guys pause and try this out yourself, and then unpause, and we'll go over it. This is a 9, by the way. All right, so go ahead and try it. Alrighty, hopefully you got 12 for x here. So first thing you do is label. You can see that your hypotenuse is 15. This is your L legs, A and B. So this is C. Write it out. A squared plus B squared equals C squared. A is 9, B is x, and C is 15. Plug it in. 9 squared plus x squared equals 15 squared. That gives me 81 plus x squared equals 225. I have to get x squared alone here, so I subtract 81 from both sides. That leaves me with x squared equals 144. Taking the square root of both sides, I get x equals 12. All right, and that's it. Tomorrow, guys, you're going to be just practicing with more Pythagorean Theorem. And on Monday, you will have a lesson on simplifying square roots that are not perfect squares. And that will be the last lesson of the year. On Tuesday, we will just be doing a last day activity, something similar to what we would do in class. All right, so have fun with the Pythagorean Theorem. It's super important for 8th grade. It's super important for geometry, and it's also important for your Catholic high school entrance exams. Okay, guys, have fun.